Hello and Assalamualaikum. This is our video presentation Lab 6 and this video is dedicated to Sir Muhammad Anwar Adib. We are from Group 11 and I'm first presenter Nur Atira and the second presenter is Nur Shafiqah. I will explain about the introduction. For this lab session, we were given task to design and implement a given sequence with electro-pneumatic using ladder diagram based on System A and System B. In this video, we will explain the list, equipment and the explanation simulation by using Vesta FitSim and conclusion. Based on the table shown, this is our list of equipment. Alright, this is the System A description, the sequence, sensors, control valves, model, rope, gear actuators. Based on the ladder diagram, the CR1 present as group 1 and for CR2 present as group 2. I will show you the simulation for System A. After the simulation is ended, I will explain how it operates. For pneumatic circuit, when PB is pressed, 5-way valve is activated where airflow functions are pushed to the right. The pressurized airflow through the valve extends the cylinder A. For electro-pneumatic, when PB is pressed, K1 at line 1 is energized and K1 at line 9 was connected. Then, the solenoid at line 9 is triggered and then the cylinder A is extended. Next, at line 5, inductive proximity switch turned on and the K3 is energized. K1 at line 10 is connected, then K3 at same line is connected. The solenoid at line 10 is triggered. For the next sequence, in pneumatic circuit, 3-way valve is activated and pushed to the right where to extend the cylinder B. For electro-pneumatic circuit, at line 7, inductive proximity switch turned on and K4 is energized. Then, the cylinder B is extended. After cylinder B is fully extended, K2 at line 3 is energized. K2 at line 11 is connected. For the last sequence, in pneumatic circuit, after both cylinder is fully extended, both 5-way valve and 3-way valve is pushed to the left, and both cylinder A and cylinder B retracts back. For electro-pneumatic, the solenoid at line 11 is triggered, and then the cylinder A and cylinder B is retract at the same time.
Now I will explain about the System B. In System B, two double-acting cylinder, which is cylinder A and cylinder B, will be used. Cylinder A will use sustain valve and cylinder B will be used non-sustain valve. So the sequence will be start A plus, B plus, B minus, A minus. For the sensor, start will use push button, A plus as A1, B plus as B1, B minus as B0, A1 as A0. As you can see, the model graph set was arranged referring to the sequence. Sensor was located after each of the sequence. The graph set then was divided into group. In the system, the graph set was divided into two groups, which is group 1 and group 2. No actuator, which is the alphabet, is repeated within the same group. For group 1, the group activator is start and A0. For group 2, the group activator is B1. From the step above, ladder diagram could be designed. In the ladder diagram, CR1 is represent group 1 and CR2 is represent group 2. CR1 is activated by start and A0. Normally open, CR1 is acting as holding circuit. Normally closed, CR2 will deactivate the CR1 when CR2 is activated. When CR1 and B1 is active, CR2 will on and normally open, CR2 will hold the circuit. Normally closed, A0 will deactivate the CR2. There is no A minus in the ladder diagram because sustain valve was used for cylinder A. A plus will activate when CR1, which is group 1, is activated. When normally open CR2 and normally closed B0 is activated, it will deactivate the A plus and causing cylinder A to retract. B plus is activated by CR1 and A1 while B minus is activated by CR2. So this is the simulation for system B. The electro-pneumatic circuit could be constructed by referring the ladder diagram that we have designed before. So for this system, retract position will use roller switch, which is SA0 and SB0, and extend position will use proximity sensor, which is SB1 and SA1. Roller switch SA0 and SB0 is on because both of the cylinder is in retract position. When start PB is pressed, it will activate valve K1 and hold the circuit. K1 will allow current to the solenoid valve A plus and energize the solenoid coil. A plus at 5 to 2 way valve will actuate and allow A flow to the cylinder. Cylinder A will extend, and when it is fully extended, proximity sensor SA1 will active. K5 that represents SA1 will allow current flow to the solenoid valve B plus and energize the solenoid coil. B plus at 5 to 2 way valve will actuate and allow A flow to the cylinder and extend cylinder B. When cylinder B is fully extended, proximity sensor SB1 will activate. K4 that represents SB1 will allow current flow and activate K2, and K2 will hold the circuit. K2 will deactivate valve K1 and stop the current flow to the solenoid valve B+. K2 will allow current to the solenoid valve B-. B- at 5 to 2 way valve will actuate and allow A flow to the cylinder and retract the cylinder. K4 is deactivated. When cylinder B is fully retracted, SB0 is on and activate the valve K6. K6 will cut the current flow to the solenoid valve A+. Spring at 5 to 2 way valve will return the valve to its rest position. Cylinder A will retract and deactivate the proximity sensor SA1. When cylinder A fully retract, SA0 will on and activate valve K3. K3 will cut the current flow to the valve K2 and it will deactivate the solenoid valve B-. Both cylinders return to its retract position. When the start PB is pressed, it will repeat the same process again. At the end of this lab session, we can conclude that we were able to design and implement a given sequence with electro-pneumatic using ladder diagram. We can also design the ladder diagram by using two different types of valve, which is sustained and non-sustained valve.